Hello, welcome back to JK Chemistry. Today we are going to discuss about the most important, that is Maxwell's thermodynamic relations. So it is very difficult to memorize. So if you are using some trick and tips, we can derive at the instant, at the moment. Okay, it's very simple. Okay, so listen here. Okay, so here we are discussing a magic box. Okay, so first we are creating this. Here we know that it is a entropy, this is pressure, this is temperature, it is volume. Okay, U is internal energy, H is a enthalpy, G is a Gibbs free energy, A is Helmholtz free energy. Okay, right. Okay, now here first we are making a small box. Okay, these are the state variables. Okay, so S PVT. Okay, so it is the shortcut is Satya Prakash is very talented. Satya Prakash is very talented. It should be in Z manner. Satya Prakash very talented. Okay, his grade always upper. His grade always upper. Okay, this is in clockwise. We should start from here. Okay, his grade always upper. Okay, this is the magic box. This is our box. And another thing, the arrow, it is downward, this is also downward. Okay, so how can we derive the thermodynamic functions from this box? Let's see. Okay, let's see. First we are starting. Okay, U, that is we know that du, dh, da, dg, these are our thermodynamic functions. So this comes from du, dh, dg, da. So how the equations of du comes? Okay, let's check. Now before that we can have two kind of variable. The variables, that is state variables, that is near to the thermodynamic function treated as differential variables. Okay, differential variables, and away from that treated as constant functions. I repeat, if you are deriving one of the thermodynamic functions, so we know, so let's say du, so we know that S and V are functions near to this thermodynamic function treated as derivative, that is ds dv, and the functions away from this, that is p and t, treated as constant function. So moreover we know that two arrows, this arrow is moving towards constant function treated as positive, away from constant function treated as negative. Let's check. Okay, du is equal to TDS. We know that S is derivative function, T is constant function. So TDS, and we know that arrow is towards this constant function treated as positive, and then minus PdV. Why it is minus PdV? It is dV, but our constant function P, but arrow is away from constant function. So see, that's why it is minus PdV. Clear? What about dh? dh is equal to, we know that S and P are derivative function, V and T are constant functions. Okay, so dh is equal to T ds, so positive T ds, then V dp, arrow towards constant function, so it is positive V dp. Okay, what about dA? dA is equal to, these are derivative function, these are constant function. Now minus s dt. Why? Because it is away from constant function, minus s dt, then minus pdv, that is it is away from constant function, minus pdv. Okay, what about dg? dg is equal to minus s dt, then plus vdp. Okay, plus dvp. So it is very simple. So you can memorize this way. Another way also you can memorize. So let's write it in this sequence. Okay, that is UHA. We can call it as UHAJ. Okay, now we have to memorize one of the equation, that is TDS minus PdV. Repeat, TDS, change the sign and change the parameter. Here it is minus PdV, it should be VdP. Okay, VdP. Then change the sign and change the parameter. It is TdS. Now we changed the sign minus SDT. Then repeat. Okay, minus PdV. Okay, minus SDT. Okay, plus VdP. Okay, this sequence you can repeat. Okay, ready. Now we move on to our Maxwell's relation. Very important. Okay. Okay, Maxwell's relation. First Maxwell relation. So first of all we have to write this our box. Okay, we are writing only SPVT, that is Satyaprakash very talented. That's only. Okay, now we want to generate our first Maxwell relation. We start a red line from T. Okay, box like this. Okay, ready. And we should draw another line that is just covering this arrow, that is PSV. Okay, PSV. Okay, now how the relation comes? We start from here. Dou T by dou V at constant S. Dou T by dou V at constant S. Since the arrow is upward, it is positive. Now dou P by dou S at constant V. Okay, since the arrow downward, it is treated as negative. Okay, negative. Okay, now when we are moving next to thermodynamic Maxwell's relation, we are drawing the SPVT again. Okay, now in earlier case we started from T upward. Okay, now in this situation TVS. Okay, like this. Okay, now we started again from T but in another direction, that is TPS direction. TPS direction, and another arrow should be that should covering this arrow like this, that is arrow of red should be the bend of the black. Here also arrow of the red should be the bend of black. Okay, like this. Okay, now how it is? We start from T, so dou T by dou P at constant S. Okay, upward, so positive. Then dou V by dou S at constant P. Okay, again upward, so positive. Okay, ready. Now next one. Okay, again we have drawn SPVT, Satyaprakash very talented. Okay, now we are starting from S. Okay, SVT, and the black arrow should covering the arrow like this, P, like this. Okay, now how it is? We started from S. Dou S by dou V at constant T, since it is downward, minus. Okay, is equal to dou P by dou T at constant V. Okay, so since it is downward, it is again minus, so both minus cancelled, you can have this. Okay, the next Maxwell relation, we started S. Now here also we started but from S but in different direction, that is this. Okay, SPT, this direction, and another arrow should be covering red like this. Okay, so how? Dou S by dou P at constant T, since it is downward, minus. Okay, is equal to dou V by dou T at constant P. It is upward, it is treated as positive. Okay, clear? So it is very simple. So if you are given one of the Maxwell relations, okay, so you can easily find the next one. So suppose if we are asked dou T by dou V at constant S is equal to what is? Okay, you can we can check by drawing this. So suppose you are given dou T by dou V at constant S, so you can easily generate dou P by dou S at constant V. Okay, so in every situation you can see we are drawing SPVT box. Okay, now we are generating another box, leaving one of the side vacant. Initially we started from T. Okay, and next one also started from T but it is in opposite direction. Okay, so that is red line. Okay, the next line should be in such a manner, its corner should possess at the arrow of red one. Okay, that way you have to draw. Okay, that way you have to draw. Every situation you can see that trend. Okay, second situation we started from S. Okay, fourth situation we started from S but in opposite direction. Okay, clear? It is very simple. Okay, so this is the popular these are the popular Maxwell relation. And now we move on to next type of Maxwell relation. It is not much familiar, but the exam point of view is very important. Okay, for this purpose we are generating our magic box having internally SPVT, outside thermodynamic function HGA. Satyaprakash, very talented, his grade always upper. Okay, now for producing this relation we have thermodynamic function U. Okay, it's a related variable or functions are SV, H which is related to SP, G related to PT, A related to VT. Okay, now in order to produce this relation we have to consider four corners, that is S corner, P corner, T corner, V corner. S corner is related to H and U, P corner related to H and G, T related to G and A, V related to U and A. Now we are going to produce this thermodynamic relation. You just see the sequence, then you can easily produce. Okay, that is dou U by dou S at constant V. Okay, that is related to S corner is equal to dou H by dou S at constant P. Okay, so it's just like this, dou U by dou S at constant V, then dou H by dou S at constant P. Okay, that is corner is related to H and U, and each thermodynamic function is related to its own variables. Okay, same way you can generate with respect to V corner, that is dou U by dou V at constant S is equal to dou A by dou V at constant T. Okay, ready, clear. Next we can go with the P corner, that is dou H by dou P at constant S is equal to dou G by dou P at constant T. Okay, clear. Next we can go with the T corner, that is dou A by dou T at constant V is equal to dou G by dou T at constant P. Okay, clear. So in each case we are considering one of the corner, then it's related to thermodynamic function. Okay, clear. It's very simple. Okay, so subscribe, like and share. Thank you, take care.